Alrighty, good morning, everybody, and welcome to the wolfSSL live webinar on securing IoT devices with wolfSSL engineer David Garski. My name is Kajal Subkota, and I will be moderating this webinar. All attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand to be unmuted if you'd like to ask the question live, as we do host a Q&A session following this presentation. This webinar will also be recorded and made available on our YouTube channel shortly after the presentation. And I invite everyone to follow us on Twitter at wolfSSL, as well as all of our other socials. And please feel free to email us at facts@wolfssl.com if you have any additional questions. And now I'd like to give a brief company overview before we move on to the technical presentation. So wolfSSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized there wasn't an open source dual licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 50 dedicated employees in 2022, most of which are engineers. This progress is, of course, supported by a strong partner network that we're very proud of, which includes DDCI, STMicro, and RTI, for example. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, FIPS certification, and a FIPS-ready offering, MQTT up to the version 5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, a IDPS known as Wolf Sentry, as well as Java wrappers and JSSC support and commercial support for curl. All of these offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'm going to hand it over to David for the presentation.
Thank you, Kajal. Yeah, so Kajal went over all of our products here. I'm going to dive in just a little bit more on each one. And then we'll talk about IoT device security and specifically what Microchip's offerings are that we support with wolfSSL. So one of the newest things added was our intrusion detection prevention system, which is an embeddable firewall that can sit on a device. We've done the DO178 certification for wolfCrypt recently, and we're working on a FIPS 140-3 certificate. So that's the new NIST standard for working in the federal space, and that certificate should be finalizing very soon. We'll be one of the first to have it. We do a lot of things to make it easy for developers. So all of our source code is open source. It's available on GitHub, or you can download it from our webpage. And we have lots of wrappers and helpers and examples. So we have interfaces through Java, C#, Python, even JavaScript. And something else not mentioned was that we have the maintainer of curl is one of our employees, Daniel Stenberg. And so we offer curl support. And there's also a tiny embeddable version of curl that we offer. And recently we've done a lot of work to expand our command line utility. So there's a wolf clue repository and product available. And it's very similar to the OpenSSL command line tools. So again, you can download this from GitHub or from the website. All of our source code out there is GPL v2, and we also sell a commercial license that's available. So our TLS library, supports all the latest TLS 1.3 and DTLS 1.2. There is a draft that's pretty far along on DTLS 1.3, which will kick off engineering efforts for this year. So our library is built, it's all C, super lightweight, very modular. I think what really specializes us is our ability to run on really small embeddable targets, but we're also very customizable. So for example, you can run us on a desktop environment, and we'll actually beat OpenSSL performance. We have assembly optimizations and speedups also, and we can run on bare metal. So we also have a sniffer that's available. And that sniffer is able to, if you know one of the long-term private keys, or the ephemeral key from one side, you can actually decrypt all the TLS traffic. It's a neat tool. And we've done a lot of work around MISRA-C compliance for the automotive as well. So with our wolfSSL products, Microchip has specifically purchased licenses that allows use of wolfSSL, wolfSSH, and wolfMQTT for free inside Microchip Harmony and the MPLABX tools. So this is a deal that we did for 10 years, and it allows users to use the commercial version of these libraries, which was quite a great benefit to users of Microchip hardware. So the FIPS, in case anyone doesn't know, it's a federal information processing standard. Any federal agencies that are using cryptography, need to have this NIST FIPS 140-2 type compliance. Currently with the 140-2, we have 2 certificates, and we've done 19 OEs. I think the OEs number for 3389 is quite a bit higher now. And then we have several in the queue for 140-3. Our MQTT client is also lightweight. It was built, from scratch with a focus on portability and the ability to use it in a small embedded environment. We support the V1311, V5, and the sensor node versions of the protocol. And we support the secure MQTT version, which uses TLS on port 883, and that uses wolfSSL in the background. All the network interfaces are abstracted via callbacks. And of course, all our documentation is excellent. It's all Doxygen based, and you can find it all on our website. We have lots of examples. So WolfBoot is our secure bootloader. It's actually based on the IETF suite, which is now RFC 9019, which defines security for a secure boot. We support ECC, RSA, and ED 25519. We use a public key-based root of trust, which could usually gets embedded into the bootloader, but could also be offloaded to a secure element. It handles update, version checking, failure rollback. You can do measured boot with an external secure element, and it supports external spy flash as well. We support encrypted updates. We're working on AES version of the encrypted updates, and Delta updates, which is just supplying a patch between the versions. And that also supports failure rollback if there was an issue with the upgrade. wolfSSH is our secure shell. We support SFTP and SCP, and you can use password or public key-based authentication, and it is also designed for embedded use. It's all written in C. And our latest Wolf Sentry, or intrusion detection prevention system, is a embeddable firewall. It supports dynamic and static rules. We already have integration with wolfSSL, MQTT, and SSH to basically detect abnormal type activity and be able to block and prevent those. And Wolf TPM uses the 2.0 standard. We implemented all of the APIs. We have lots of examples, no external dependencies, and we support all the features like parameter encryption and authenticated sessions. And we've done a lot of work to make it easy to use a TPM and things like TLS, or just basic things like creating a private key and creating a certificate based on that private key. So what is an IoT device, and what are some of the security best practices we recommend? Well, IoT device is something that's internet connected and usually resource constrained. It typically connects to a cloud, and it can sometimes be referred to as like an edge type device. There's lots of applications within home automation, smart industry, and connected cars even. So some really common type of attacks, would be like a denial of service or brute force attack against it. You can also impersonate the authenticity of the device. So you could, make a device and try to claim to be something that's not. There's attack vectors against physical keys or replaying of captured messages. There's another attack vector where you could be in between the cloud server and the device, and you can act as a man in the middle. These are just attacks that people deploy. And then another one would be physical attack of the board, through firmware. These are all things that we need to guard against in IoT. So things you can do, one would be a secure boot. So you want to make sure that you are authenticating the updates that come down. You want to make sure you have a proper root of trust, based on ideally a key and a certificate. For the private key, utilize some type of protection of that key. So like OTP, one-time programmable flash, something like an @ECC or an @TPM2 2.0, which I'll talk about a little bit more. And then, with the certificates, making sure they're issued from trusted CAs. Another thing would be, unique device identification. So you could potentially include that in the certificate. And then TLS, definitely recommend version 1.3, which only supports, ephemeral perfect forward secrecy AEAD type algorithms, which are the most secure. And if you are looking to do session resumption, the session tickets is your best option. Also, something to consider is revocation. So if a certificate or a key is compromised, then the ability to revocate that and issue a new one. And OCSP stapling is a really good option. So with Microchip, these are a few of the security solutions they provide. These are secure elements. So external secure hardware solutions. One is the @ECC, which has been around a while, and it is a small device that uses an I2C interface. There's also a new TA100, which is an automotive grade coprocessor that they've created. And then they have a TPM 2.0 module called the @TPM2. So with our integration on the @ECC, I'll talk about that a little bit more. So, it has basically a secured I2C interface. It supports only the NIST, 256-bit, R1 curve. There are up to 16 key slots, which can be used for different purposes. And there's also some NV, non-volatile storage space that you can zone and use for things like certificates. And Microchip has done a lot of work to really simplify the provisioning. So they have these Trust and Go, Trust Flex, and Trust Custom, and some of the things are really simple. So like Trust and Go will already have provisioning for, let's say, AWS or Azure. Trust Flex lets you customize it a little bit more, and then use their CAs, and then Trust Customs if you wanted to use like your own CA and everything else. And you can see this link on the webpage to just with more information on how they do the provisioning, which is quite great. So our stack integration, we did it at the TLS layer, right? So anything like the RNG or all of the ECC operations, those are all offloaded to the chip or can be offloaded to the chip. And these are some links for where we have our product documentation around it and specifically how you implement it in the code. I did grab some benchmarks. So this is something we did fairly recently on a @ECC 608. And it's talking about how many times per second you can do a key generation or a shared secret, an agreement or sign verify, which these are quite excellent numbers. So we have several demos available. We've actually created a repository just for @ECC demos. Originally started with a PIC32MZ demo, and then we've added a couple more for the SAMD21. We also have an expressive ESP demo. So for the PIC32MZ, it was this Curiosity 2 board, and there was a crypto, this is the @ECC microbus connector, and then there was an Ethernet interface. And so that full example with MPLABX and Harmony is available here. And then we also did one for wolfSSL and wolfMQTT connecting to Azure. And for this one, we used this crypto auth trust platform. And this board has a SAMD21 plus some @ECC options. I think there's 3 different chips provisioned different ways. And then we added on the Wi-Fi, the @Wink 1510 module. And so we were able to with this is this secure cloud demo connect to Azure in that. There's also a demo out there in our wolfSSL IDE expressive directory for the Room 32 SE, which actually includes an at ECC 608. And that has a TLS client server demo. Okay, so I went through all that pretty quickly. Hopefully we've got some great questions to come out of this. So, and I am happy to show some of the tools, but I wasn't planning to present that specifically. So.
Awesome.
Yeah, Kajal, do you want to cover any
Yeah.
questions?
Of course, we have, as a reminder, please feel free to use the Q&A box to ask your questions. And we have a question right here. Any common criteria from certified secure elements from Microchip?
Ideally, someone from Microchip could answer that. But so as far as I know, most of those modules, if not all of them, actually have FIPS and common criteria certifications. And I don't have the specifics on that.
Awesome, thank you. For Microchip MPU, A7, A5, and ARM.
Right, so those are microchip processors that have the ability to run something like Linux. So that is a really easy thing to do, is basically building wolfSSL or any of our libraries, for a Linux target. Is that something we do out of the box? You can cross compile or run directly on there. And we have lots of instructions for that. And all of those libraries have example projects to cover those things.
Fantastic. I'm curious about Wolf Sentry. Is it a firewall interface?
Yes, so it is an intrusion detection and prevention system. So what that means is it's acting as a single firewall layer, interfacing to, let's say, a TCP, interface for services. And it's aware of the type of service on that port. So let's say you're running TLS on a specific port and you've told Wolf Sentry about that. It can actually look for abnormal type, and it will look for abnormal type traffic and implement active blocking against it if there is something that it detects as an intrusion. And it's designed to be really quite lightweight and very easy to add new rules. And it's designed to be aware of the types of protocols that are running through your device, like SSH or MQTT, anything like that. So.
Fantastic. If you use wolfSSL in your product, what can we claim in terms of FIPS certification? And does that mean our product is FIPS certified?
Yeah, that's a great question. So all of our WolfCrypt code has been through FIPS multiple times, but the versions that are actually certified, from that certificate are very, they're similar, but they're a very specific version. If you want to claim being certified, you have to run that specific version. There's also a layer of FIPS code, which you can see a lot of it in the FIPS Ready download, but there's things like a boundary around the crypto algorithm, and there's integrity checks for that. There's also self-tests that run. All of that being said, you would need to license the FIPS code, and it would have to actually be an operating environment that we've already certified. So an operating environment is a specific RTOS and hardware. If it's not one that's already been certified, then you would typically need to add an operating environment for your specific hardware. Ultimately, it is the federal customer that you are building products for that determines how severe these requirements are, right? Most federal customers are going to require that you go through the process of doing the certification and adding the OEs for your specific hardware, which includes, automated test vectors, code reviews, a bunch of things that you go through. And usually we can take our library that already has a certificate and add an OE within 1 or 2 months on somebody's platform. It's pretty easy. It's something we've done quite a few times now. But yeah, hopefully that answered your question.
Awesome. How common are TPM chips in IoT devices today, and for what applications?
I really like that question. So it's becoming much more common. TPMs originated in the servers for UEFI, and they've since moved to desktops. Windows 11 is going to have it and uses it for BitLocker. But in embedded IoT devices, TPMs are really great. So they're small, standardized module. You have several vendors to pick from. What we're finding is that most people are using them for a couple things. One would be TLS authentication. So the long-term private key associated with your certificate is actually residing in the TPM. Another thing is the measured boot, which is really handy. So they have these PCRs, platform configuration registers, and Wolf Boot, for example, can actually update that PCR as it's booting, and the application can actually verify that nobody's tampered with the boot process. I would say some other common use cases are around the NV. So those are some really handy things you can do with the non-volatile storage on a TPM. And well, there's lots of things. So if you go to our GitHub Wolf TPM, you can see some of the examples. There's some other things for like sealing and unsealing a secret, based on the state of a PCR or some other type of authentication. There's also this attestation, which is really common. And you have the ability with a TPM to attest something, which is basically a form of signing it. And the other party can actually verify that you really did have the TPM. It's part of authentication. And so we have examples for that too. That's a great question.
Fantastic. Is Wolf Boot integrated into Microchip/Harmony?
That is a good question. I don't believe it is yet. And I don't remember if it's part of the license either. Let's see. Accidentally jumped, sorry. Yeah, so Wolf Boot, one thing about Wolf Boot is it's running in bare metal, so it's not really dependent on RTOS or any specific, type of platform. It would be very easy to run it on a Microchip hardware platform, and I think we've had conversations with adding Wolf Boot as one of the supported, products within Harmony, but I don't think we've done that work yet.
Fantastic. What exactly is executed on the ATECC complete TLS protocol, or only the crypto?
So just the asymmetric operations. The ATECC does have some support for symmetric, which would be like AES or SHA. However, it's an I2C interface and it's quite limited as far as performance. So the one thing that most people use it for is like the ECC portion of TLS, which is the ephemeral key that's created, the shared secret that's computed, and the signing or verification. So that ATECC coprocessor can be much more efficient at those things, and it has physical hardware protections for the private key to make sure that it's safe. And that's what it does really well. And that's what most people use it for, is the asymmetric ECC type operations.
Awesome. How does wolfSSL helps the secure boot process? Is it that ARM specific?
So Wolf Boot is not ARM specific. It was originally designed around the ARM, like a Cortex M4 type platform. And since it's been expanded to, PowerPC and a few others, specifically what it's doing is verifying the integrity of your application. So on each boot, right? So it does a hash and it verifies that the signature on the front of it is valid. It also has the ability to do updates. So verification of the update that's coming down, and the ability to swap two partitions, potentially others, but to swap two partitions specifically in a way that keeps the integrity of the two. So you always have the previous version of the image as well that you can roll back to. It also does version checking on those to make sure that somebody isn't trying to do a downgrade type attack. And then there's lots of other things too. If you go to Wolf Boot on GitHub, there's a docs directory, and there's some phenomenal documentation in markdown format there that describes this more.
Fantastic. The MQTT client supports secure MQTT. Does it also support MQTT over secure WebSocket?
That is a feature request that comes up often. So secure WebSockets is actually like HTTPS. I think there's a way to do something similar to that. And if you go to our GitHub issues, there's been a few people asking for it, and it is something on our roadmap this year. Currently, we just do MQTT plus TLS, and that's all we support at the moment. Doing the WebSockets is definitely something we want to do.
Fantastic. Do you handle policy authorization or extended authorization introduced in TPM 2.0 from wolfSSL?
That's a really specific question. So we support everything in TPM 2.0 as the specification goes, including all the methods for authentication, so password-based or HMAC, authenticated sessions, all of those. And I wrote most of that code personally, and those terms are a little bit gray. So I think that's a really specific question. And if you want some more specific answers, I would suggest emailing us, at facts@wolfSSL, and that's FACTS at wolfSSL.com. Happy to dive in more on that. So
Awesome. When is wolfSSL support for the draft DTLS version 1.3 standard expected?
Well, it's still a draft. Last I checked, it was 48. It seems to be stabilizing. We've done estimations for the work, and we're probably going to kick it off this month. And I expect it would be done 2 to 3 months from now. That would be the earliest I could foresee having support for something like that. But it is immediately happening. So.
Awesome. And I think that was our last question. Thank you, David, for a fantastic presentation. And, as a reminder to everyone, this webinar is recorded and will be made available on our YouTube channel shortly after the presentation. If you would like to receive a copy of the slide deck, please feel free to email us at facts@wolfSSL.com, and we'll be happy to send that over to you. And again, if you have any other questions or comments, we'll be happy to help you if you just email us at facts@wolfSSL.com. And I hope everybody has a fantastic day. Thank you so much.